Happy Monday. We're going to be doing some assembly language programming today. We did a lot of assembly some previous streams. This time we'll be going through a refresher of the things that we went through so far, and then proceed onward to chapter 3 out of a whole bunch of different chapters. There's a lot of different chapters, and there's a lot to learn with assembly, and I'm having a lot of fun with it. It's becoming obvious what's going on, what's happening. We'll walk through some of the code again just to get things started. We will look at the beginning of the tutorial, and we'll read through it. We'll read through this together. So here we'll start here at the top of the screen. If you're going to walk through this tutorial with me, or if you're at a computer, you're going to be needing to use a terminal app. This will give you access to the command line and will allow you to execute the assembler and the linker. You'll also, if you want, you could use a terminal window to edit the assembly files directly, or you could edit the assembly files in your favorite text editor. You don't have to use the terminal. To get started, let's see if hey, how's it going, Eddie Legendary? Welcome on in. Happy Monday. We're going to be doing some assembly today as requested by Kevin McAllister. Kevin McAllister's like, hey, maybe we should do more assembly. I'm like, okay. It's been a while, so let's see if we can revisit some of the things that we've already looked at. So we're going to be doing, this is the hello world of assembly. So essentially it's hey, Kevin McAllister, hey, buddy, yo, you're here just on time. This topic was requested by you, and so we're going to get back into it. We're looking at assembly. Hey, Neva, how's it going? Good to see you, Neva. Happy Monday. I didn't see your game stream this weekend. Oh, hey, no worries. We still have to do that. Yo, Kyle, how's it going, Kyle? Good to see you. I've been looking forward to this stream. Nice. Me too. It's a lot of fun. Hello, guys. Hey, this is fun. I'm going to do some unsafe code now as well. That's exactly this way here. One of the things about assembly and other common programming languages like C, low level, it has some risks associated with it. You got to be careful. But you have a game stream. It's mostly just creating a game. So we built a game in PyTorch with Pygame and PyTorch to have an AI learn to chase your character on the screen. We converted it to C# for Unity, and we need to do the follow-up stream where we actually launch it and put it into Unity, build it, run it, and then deploy it on an app. That's what we're going to do. We're going to do that. More hacking saw movie hackers. Oh, yeah, 1995. Assembly language, was it? Yeah. Yep, you got it. No, I do Rust. Everything unsafe. No, because it's fun. No, don't do that. Never, don't do that. Hey, Bubble Bear. Hey, how's it going? Welcome on in. Happy Monday. All right, you guys, we're going to be doing some assembly. We're doing assembly. We're getting back into it. Oh, I thought you streamed your game play during the weekend. Oh, no. That would have been fun. I did play some games. You subscribed? Nice. Guitar sounds great. All right. Person in turquoise waving. Thank you. It's called Crust Unsafe Rust. Yeah. Yeah. Weren't you going to play your with friend like Minecraft or something? We played Silk Song and we beat it. We beat Silk Song. We beat Silk Song this weekend. Only 49 hours. Only 49 hours. Back in my day, we hacked the phone lines. Oh yeah, it's called phreaking, right? With a PH. Phreaking with a PH. Okay, let's jump into it. All right, so we have a terminal window. Crust is a real thing, by the way. Is it really unsafe Rust? That sounds dangerous. It sounds dangerous. To make the Hello World applications, this tutorial already made some changes, so it works on ARM processors better. This is neat. This is really neat to know. On your ARM processor, they like everything even numbers. Actually helped the guy who coined Crust on his B compiler. Did you really, Neva? Did you stream that? I did not. I didn't stream it. No, I didn't stream it. That was all just sitting in the living room, hanging out and having a lot of fun. That's what that was about. Okay, so apparently when you align, which is how the bits are aligned when data is assigned and you're passing data between registers, the alignment is how data is packed. And you want to do things in chunks, right? So I do believe this is the alignment chunks. It likes it to be in even numbers. I don't know why. It seemed to work before when I put it into odd numbers. I assume that it automatically fixed that for me. But you beat it. Nice. We did. We beat it. We defeated it. So the system call in Linux and Mac OS have several differences due to the unique conventions of each system. Here are some of the key differences. Function number. The function numbers differ between the two systems. Wait, really? Linux using 64 and Mac using 4. Really? On the table for Darwin, system calls can be found at, okay. So there is some sort of, I want to see what this is. Wait, we need this. I've been wanting this. This is something I really want here. All right, let's grab this. We're going to copy this here. Copy that, and we're going to go over to a browser tab, and we're going to bring this in. I want to see this. I'm excited about this. Check this out. This should be, oh yeah, I think, is this it? Wait, what is all, is this what I want? Exit, fork, open, wait, what is, no, all, wait, what are these things? Is this what I want? I don't know if this is what I want. I don't know if this is what I want. Would you like, okay. Let me see here. Is it? No, I want system call. I want all the supervisor calls. I want all the supervisor calls. Though I can't tell if this is it or not. I cannot tell. Let's see here. Let's go to chapter 1 and just open up the assembly file. So 4. So 4 would be the right system call. Number 4. Number 4 is the right system call, right? So number 4. So if we have number 4 is the right system call, then number 4 here, I should say right? Number 4? Nope. So that's not what I want. This is something else. This is not what I want. I want something. I want something else. Hey, Torval, how's it going? Welcome on in. Happy Monday. So alignment is good for speed and sometimes required. Yes, these days we usually don't require it because we have an unaligned version of everything. And at that point, it costs 0 and not require. Okay, good to know, Neva. I know that from performance perspective, the larger alignment that you have, the faster things can be. Well, it depends. Like if you're using large chunks of data, you want to have larger alignments. If you have smaller chunks of data, smaller alignments, I assume. The cost is waste on memory. So if you align something to say, I don't know, 6, a really big number, I don't know, let's say 8. However, you're only really using 2, then you're wasting 6 bytes or 6 bits, somewhere along that. You're essentially wasting most of the memory on the machine. On the higher level language, alignment can be used for some tricks, so it's still required. There we go. That's good to know. Thank you. That's good to know, Neva. All right, so let's bring this back over here. So I know here, I want like all the supervisor calls. So like number 4 is for writing out to the system. Your first register is going to be used to reference the file descriptor. So is it going to be standard out, which is 1? Standard out will be 1. Is it going to be a file? It'll be something different. You'll need to ask the system to give you a file handle, right? A file descriptor. So I know there's more to it. To be able to write a file in assembly, I assume that's going to be this is going to be an advanced segment. It's going to be advanced. I know. It's going to be advanced. Let's see here. Okay. So let me see. Let's see what else we got going on here. All right. Okay. System calls. Yeah, see, system calls in Linux. That's what I wanted. Using number 4. And then I opened this up and it's not what I wanted. It's like, caution, Darwin numbers are considered private by Apple. What? And are subject to change, therefore only educational purposes. Okay. That sounds like a huge warning. Danger zone. The Darwin function numbers are considered private by Apple. It's going to be dangerous. Writing a file is not hard. Just open the file, write, and then close. That's what we wanted. We'll eventually get there. We'll get there. I assume so. I know that you have to ask the operating system, the supervisor, to give you a file descriptor. So there must be a system call to get the file descriptor. I know that. I saw a YouTube short that really didn't really get it's mentioned to be funny, but didn't really code. So got it. Hey, no worries. Don't really get it. I sometimes don't get it either. I sometimes don't get it either. Those are all sysx all calls, like 3 calls. Oh, multiple in 1. Really? So we're going to learn some new things eventually. Hello, The Last Attack. How's it going? Good to see you. Happy Monday. We're doing some assembly. We're doing assembly today. Okay. So to make the linker work, a little more is needed. So Actually, it's not that hard. I remember doing this. I remember this. So let's try this really quick. Let's see if we can get back up to speed with the first hello world. So let's copy this. Copy. Okay. And then we're in the first, let's see, CD chapter 1. Okay. So let's see if we can remake this. So let's open up this make file real quick. Okay. Is it the same? Does it look the same as this? Hello world. Sys calls, 3 calls, open, write, close. Got it. Okay. So just 3 system calls. Misspelled, sorry. Hey, no worries. Okay. It totally makes sense. We need to do 3 system calls. Open. Okay, open. There we go. Open. So open is going to give us the file descriptor number. That's the thing that I was thinking that we needed. The open system call is going to give us the file descriptor. The write system call, easy. And then close will close the file descriptor. There we go. Easy. So let's see here. It totally makes sense. That totally makes sense. Let me see here. Does this all look correct? Hello world.o for the object file. And this will be, okay, so this will assemble and this will link, right? So these are 2 separate things. So we've got two phases here in the make file. With the output will be O, and then we link it. Okay, so LD, L system. So which do we do? What happens first, right? So it seems like this happens first, right? Because we need to make the O file, and then we assemble it over here. Oh, Eddie Legendary, I saw you posted a link on YouTube. What is? Oh, okay, got it. Oh, wait. Let's see here. All right, 1 second. Okay, general. Oh, wait, I saw that. That was really funny. Was this the HTML Flappy Bird? Yeah, I remember this. I liked that. I thought that was funny. I sent that thing on the Discord. Yeah, you did. Just happens the first LD ladder. Oh, got it. Okay. Assembly first. That's what I thought. Because the linker has to come last, right? So assembly first, and then linker second. That makes sense. That absolutely makes sense. Happens first. Yep. AS first for assembly. LD second for linker. The assembly and the makes O files, and the linker links. And the linker links. The LD links it. There we go. Okay, so we should just be able to run make, and that should work. So ls rm hello world and .o and hello world. So that will remove all the build files. And so if we run, so let's see, if I make file real quick. If we just run the assemble, so assembly first, right? We assemble. That will make the object file. Let's see here, which is right here. The object file right there. I mean, you got to assemble before you link, right? You do. You got it, Kyle. You got it. Got to assemble before we link. All right. Let's see here. So that's the assembly, right? So let's see again. So now we can do this right here. So let me see here. Let me bring this over here. Let us do this and then / this. Okay. So we should be able to copy and paste this right here. And let's see here. Let's do this. Copy, paste here. All right. And then we should be able to run that. Okay. There we go. And that creates the binary. What's restream? Wait. Why do you ask? I'm actually kind of curious. Why do you ask? It probably here. I'm gonna look. I'm gonna. 1 second. It is a tool that lets you stream multiple formats. So that's what I'm using right now. Let me see here. 1 second. Let's see. Vision Studio. Let me go over here. 1 second. I'm gonna check on. I'm checking on something. I'm checking on a thing. Let's see here. Lives. Okay. A thing. Let's see here. Wait 1 second. Okay. Where do you see that at? Where's that showing up? The stream's bio? Oh, really? Okay. Let's see here. I'm gonna, 1 second. The screen's gonna go dark. 1 second. Okay. I'm looking through. I'm looking to see. So there's no like watermark, but there's some. You said there's something showing up there, like what is it? Let's see here. Like the description. Oh, got it. Okay. Yep. All right. I see what you're describing now. I see it. I got it. I see it. That means that I'm not paying for it. That means, okay, we can fix that. Thank you for pointing that out. Okay. We'll fix that later. We'll fix it later. Okay. So now what we've done is we've assembled and we linked, and the file, the actual assembly file, hello world.s. Very simple assembly. Well, branding. Yeah, it is. It's branding. You got it. The software injected ads. It sure did. I'll be able to fix it. I know how to fix it. We'll make it better. Okay. So 1 second. Let me double check here. Okay. Interesting. Okay. Interesting. Okay. Hey, can someone suggest me the best way to learn networking, please? Milan. Milan. Good question, Milan John. Networking. So you probably start off with some YouTube tutorials. You'll also want to get your hands on. You want to get hands on, right? If you get your hands on your computer, your system, you'll start interacting with various tools. There's a lot of different tools. Some like ifconfig, right, for consumer level configuration, that will give you access to. It shows all of your network interfaces. And then what IP addresses are associated, what kind of network interface it is. Is it like a wired connection? Is it a Wi-Fi connection? Yeah. Thanks, Kyle. Thank you for that statement. So there's a lot of things. There's a lot of ways to learn networking. Definitely check out various YouTube tutorials just so you get an idea of what's possible. Then get your hands on. Get your hands on it. That's like the best way to learn, because once you interact with it yourself, you will have a good time remembering, and it's a better way to remember. It's a lot. It's like applied. You do applied. Okay. So let's walk through the berries getting started. Hello world on the what we got here. So start is the entry point to the application. Is there a chance computer science is needed? Major or a career? Well, I don't know, Neymar. I don't know, because in 2024, software engineering bench and the code LLM generators, the LLM coding generators, right? The vibe coding could solve 10% of software engineering bench problem set. 10%. Not a lot. Good though. I mean, it's a good start. Today, look at this. Today, it's so much fun. Look at this. SWE bench. Here we go. Check this out. Software engineering bench. Look at this. 74%. And that's just in about a year or so. That's just about a year. So I don't know if you actually need computer science. Well, it's still going to be needed. It's just the accessibility to do the things that you normally need a computer science degree for is going down, because look right here, 74% can be solved by computer. And now, just imagine a couple years from now, it's going to basically be good enough to do everything. Oh, Wireshark. That's right, Kevin McAllister. Good point. Milan, Wireshark is something else to check out because it lets you monitor network traffic. Thank you, Kevin McAllister. Thank you. You can access all the network packets that go through the system. That's a good idea, Wireshark. There's also TCP dump. You could do TCP dump, which is the same as Wireshark, but on the terminal. It's on the terminal. Actually, I think Wireshark is TCP dump, but with a nice pretty GUI. Well, I mean, technically an advanced GUI. Let's see. Did you sorry, missed. Let's see here. I'm going to zoom out. Did you restream add that to your bio? I didn't do it on purpose. It's because I'm using a free version, and we'll figure it out. I know how to fix it. Seems like training on testing. It is. That's what it's doing. You got it. I feel like I've heard about Wireshark before. Yep. It's a thing. It's a way to introspect all the network packets that are going through your system. How's it going, the tech man? Hello, welcome on in. You really believe that data, you don't think it gets tinkered with? It does a bit, right? They are optimizing these models to be able to specifically solve these problems. So there's a little bit of it in there. There's a little bit. Although, like, even you know, Kyle, using these code generators and myself, they're getting really good. They're getting so good. It's really easy to use them now. But it's true that you learn math and some else pure programming these days. That's also true. Like, you still kind of need it. Yeah, all these benchmarks are tricky. Some of the time the model see either the code directly close to it. Right, Neva? I know, right? They're definitely optimizing on them. Let's see. Let's get back to some. All right, so let's see. Wireshark, random ports. Yep. Oh, you could if you wanted to. You might want to use a port scanner though for something like that. If you want to do that, you could use a port scanner or Nmap, right? You could use Nmap, and that's another one. Think of something different. No, Nmap. Yeah, try Nmap. I think you want Nmap. OpenAI had a very egregious case of doctoring the benchmarks, did they? Well, they're trying to stay on top is what they're trying to do. So I believe it. It seems realistic. Wireshark's just a network monitor. You can monitor what connects to your computer. Yeah, exactly. So Wireshark and TCP dump will allow you to see what traffic is occurring on your local system. And maybe your LAN as well, your local LAN, your local area network. Nmap will allow you to scan for ports on other people's computers, right? If you are looking for penetration testing ideas, the bench don't match what these tests say. I see. It seems like it, right? I started play where, let's see. I started playing where wins meets the good as it begins literally free in comparison to $60 games. Is it a good game? All right, the tech man, tell us more about it. Yeah, they removed questions they failed on. Did they? It's a live. We're live. Hey, we're live. Not a premiere. It's a live. We're full on live. 1 second. I'm going to see if I can go over here. I'm going to click some buttons. Let's see. Go to studio. There we go. Content. There we go. I wonder, can I modify? Okay, let's see here. Yes. Okay. Perfect. Done. Save. Okay. Description fixed. The description is fixed. Okay, we're good to go. Live is fixed. It's a live. All right. How do we ascend to coding of floaty devs? How's it going, floaty devs? How do you ascend? Well, practice and building stuff with your hands. That's the way to do it. You probably want to code a lot. There you go. Exactly. This is live. Yeah, we're live. Yeah, well, of course. Exactly. Kyle, exactly. You know it's live. Fun fact, part 2 of the conscious robot is out. Is it? Oh, no. I don't know. I was concerned about that. It made me feel weird. Like your ARP lists. Yes, your ARP. The ARPs, you guys. The ARPs. Thanks. So tutorials are good, straight to the point, starting point, right? Is there any better way? Milan? Yep, hands-on, like Kyle just said, hands-on, hashtag hands-on. Hashtag hands-on. All right, so let's walk through the very basics of this Hello World program here. This is going to be printing out, I do believe this is going to be printing out. We're going to do a supervisor call. We're going to be moving data into registers, and we're going to have an entry point of start, which tells the system where to start running the code, right? There's a start. And so here's the start, right? The start's right here. You can see it starts. This is the start, the global start. This is the start of the program. The first thing we're going to do, and this indentation is just for pretty. You don't need to do that. You don't need to do that. So let's close this really quick. You don't need to do that. We should be able to chapter 01. Let's go with this. Oh wait, I hear an alarm going off. 1 second. I gotta go real quick. I gotta go. 1 second. I hear an alarm. 1 second, you guys. I'll be right back. All right. Here we go. Not as egregious as completely either faked or paid to study a fake or answer the trolley problem. Oh, the trolley problem. Again. Hey, Neymar, how's it going? All right, so check this out. Well, I'm going to buy in 2 to 3 months after my exams and then grind Silk Song all day. That's the best. Fire alarm, oven alarm. We cook some vegetables. You guys. So the oven went off, so I turned it off. Now we're good to go. We'll have vegetables for a few days. Okay, so let's see. Make. You run make. All right, ls. Okay, so vi. All right, here we go. Assembly file. You know what? Let's bring this up to the top. Let's bring this up to the top here. The top window. All right, here we go. All right. So the start function right here. And then if we open up the make file, I do believe underscore start should show up. Here it is right here. So you see the underscore start show up there. It's looking for that because that's the E for entry point. I assume E, right? E for entry point? I'm pretty sure. Yeah, because the stream is fire. Hey, thank you, Torva. Steven, what do you cook with the best? Vegetables, and I like vegetables. Hello, good evening. Marwan, hello, good evening. Of course you cook code. Code, yeah, there we go. I should have said code. You're right, the tech man. Of course, I should have said code. You're right. I should have. Okay. So, let's see here. Start, and then the start is here at the top. Here we go. I tell you what, here we go. Let's do this. Let's close this. Actually close it. Thank you. Okay. Move. So now what we're going to do, move, we're literally going to take a literal number 1, and move it into register 1. So we're going to move it into register 1. I'm going to make this, I do believe we should be able to do that. Start. You should be able to do this. I do believe you should be able to do this perfectly fine. Cooking stream when? Well, I don't know if it's just putting vegetables in the oven. That's not really cooking. There's not much to cook there. So you need to open at 56, and close at 57. Wait, what? What? Wait, what do you mean? Let them cook. All right, we'll be there. We'll make it happen. It's gonna happen. And right at 64. What? 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 Oh. Are you talking about the number? The syscalls numbers. Oh, thank you. Hey, yeah, okay. That's what you're describing. So I want a list of all the syscalls. That's what I want. I had the list. I put it somewhere, and I need to go find it. Because all the system calls, right? So this is like number 4 is to write, right? Number 4 is write. So you said number 57 is close, and number 64. For me, it's write, but maybe 64 is write to file. Is that different than regular write? Is that different? How's it going, Carmu? Good to see you. What's up, bro? We're doing some assembly. We're starting over. We're like doing a quick little rough reintroduction to see where we were left out, and then we'll move on to the following chapters. So we're just doing a refresher. Make an AI which cooks for you. We could, right? We could make an AI that cooks for us, so we don't have to do any cooking. What exactly is machine learning or AI machine learning? Machine learning, the way I think of it, is where you've written an algorithm in a process to allow an algorithm to update data storage as it sees data samples in an algorithm. So that's the machine part that's learning. It's able to collect, capture data as input, vectorize it, process it, do a backpropagation, and then update memory or data, right? Essentially memory or parameters, update the parameters, and then store them. That part I call the machine learning. And whether it's AI or regression, it's kind of all machine learning. And then the inference stage could be maybe the intelligence part, the AI part. That's kind of like, I kind of see it like that. And now they're like Venn diagrams, right? There's bubbles and things like that go around it. Can we complete the game today? We kind of completed it. We have to, the tech man, we have to import it into, what is it called? Unity. So we're almost there. This changes depending if you're on Apple or Linux. Got it, Neva. Okay, I assume Linux Arch. Got it. Yeah, we're on Apple. I recently saw a video that's pretty funny. Sadly, it's no longer Halloween. If you want to watch it on Discord, all right, Torva, we might check it out here in a bit. If you get stuck on a different planet, would you be able to build a computer there? Yeah, probably. I would. A very slow computer. Mostly, though, I would be trying to survive. So, probably. And if it's another planet, then there might not be much food around. So, I guess might as well build a computer, right? So, you deserve more views. Oh, thank you. Isaac, thank you. So, program that runs itself and evolves. God is major are cooked. Oh, well. You can think of it like that. It reminds me of movie Martian. All right, with what's his face? Matt Damon in The Martian. That was great. I like the movie. Active interface. Oh, active inference. The active inference, right? Floaty devs. The active inference. I kind of think of as the artificial intelligence, right? Because you can have a whole bunch of numbers, and they could be used as parameters to do inference. Though the intelligence wasn't learned, and so it's not yet artificial without machine learning. You need the machine learning part first to train the numbers. Then you can use the numbers as the intelligence that's artificial. On data science project, I was thinking about using Python to go through all my photos, extracting the GPS to SQLite, and then finding places you've explored in the city. That sounds like a great project. That sounds like a really good project. Time for Mr. Blum to go to another planet. No, I like it here. I want it here. Or am I already from another planet? You don't know. Real human over here. Real human, not alien. Wait until you guys find out about the reverse Turing test. Tell us more about it, Kyle. Okay. This should build, I believe. So we should be able to just run make. Let's just run make. Okay, so that still builds. So we changed up some of the syntax. All right, so move to register 1, which we're going to set the value 1. This is the register 1. We're giving it the literal number 1. Just the literal number 1. And this is the input parameters to the function that we're going to be calling. And then parameter 2 is the pointer to the string that we're going to be printing. And that is defined here at the bottom, line 27. Is Stephen an alien? Or is it just a theory, Stephen? A theory. I don't know. There's no way for you to know because we could either be in a simulation and there's no way for you to know, or I could just be an alien on YouTube. An alien on YouTube. You don't know. Could be an alien on YouTube. Steven is AI, or it could already just be AI. We're in the computer. No way for you to know. Pretty soon though, we're getting close. We'll be able to start live streaming what looks like real video. Steven becomes robot. Steven becomes alien. I know, right? There's no way for you to know. You can't tell. You cannot tell. All right. It's all deep fakes. All of it's deep fakes. All of it. You can't trust anything. Though, just be critical. Just question everything. Trust things. Trusting is okay. Questioning is good. Okay. So register 2, or the second register, which is register 1, right? Register 0, first register. Register 0. It's confusing. I know it's confusing. Don't worry about it. X1, which is the second register, will be the starting point, the address of hello world, which is the string. And then X2 will be the length of string. So you can say less. You can reduce this, right? You can drop that down and it will print fewer characters, right? It'll print fewer characters. So how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Because this is a new line character. It's a new line character. The multiverse, if Steven, it could be trust but verify. Trust but verify. There you go. That's the phrase I'm looking for. That's the phrase I'm looking for. Hey, Jonathan Bedell, thank you for your subscription. Thank you for your subscription here on YouTube. I appreciate it. Appreciate your YouTube subscription. Happy to have you here. Like the X array. Well, in this case, I don't know. I don't even know. Is it like an array index? I don't know if it is. I think it's different. Kevin, to which extent, what could you in theory do? Analyze your behavioral pattern of choosing paths and then train an AI to view which street you walked. You could. That sounds like a fun project too, Torva. You're talking about a fun project too. I sent a link on Discord of Mac OS Syscall. Oh, you did. Kevin McAllister, trust but verify, please. Okay. Thank you. All right, here we go. Let's look at this. Is this it? Is this it? It is. It is a whole bunch of system calls, but I need the associated numbers. I need the numbers. So let's see here. Let's see real quick. So here, if you take a look, so these are different system calls, it looks like. I need the supervisor reference ID numbers. For example, right. See, yeah, so see, I've got this right system call here. That is, what is that? Where is that at? It's actually number 4. So that's number 4 here, right? And so I need the numbers. Is there a way to see the numbers? I don't see it. I don't see it. Steven is a character from Parallel Universe where people are seriously proper and polite. You know, I could be. You never find out. Check out Torva's thing on Discord. Let's see on Discord. The jack-o'-lantern. Oh, that's that's a Slack symbol. That's the Slack symbol, you guys. All right. Let's see here. Copy link. 1 second. All right, Torva. We're gonna check this out really quick. Copy link. Where's that at? Copy link. Here we go. Copy link. All right. Here we go. 1 second. 1 second.
Which
is it? Are you sure this is what you want to show? You want to show this? Okay. Let's take it. We'll zoom in on this. All right. So it's very neat looking. It's very neat. Okay.
is specifically designed to terrify my neighbors who work in tech, because they'll be walking by thinking they're done for the day, and then bam, they're back on their phone. It's got a motion sensor up here. It's got a little speaker hiding over here.
Yeah, it would terrify people in tech.
This really gets the dread going for me.
Okay, yeah. Thank you, Torva. Thank you. Okay, yeah. So, that's the Slack sound, and if you hear that, that means someone's saying something, and you got to go check it out. Oh, that was pretty funny. Thank you. Steve is the type of person to hack into their ex's computer, fix a bug. I could. You never know. That's what I call a classy woman who's got health issues. When it comes to the only person that believes and trusts it, she'd rather play games. I see what you're describing. Gotta be careful. My friend's back. Okay, cool. Kareem. Sounds great. Say K-OK without your... I don't think... John Killer? I don't know about that. The trauma in your eyes. I know, right? Yeah. The AI is going to ask Steven if he's deterministic. Right? Because these AIs, they're non-deterministic. Right now, they are not. Eddie Legendary, please explain. We have this thing at most tech companies, or even any company really, will have a team chat channel. Like Discord, it's called Slack or Microsoft Teams. And they have these sound effects that mean that someone is talking. Steven is AI God. We could be Karmu. We could be. You never know. Okay, so standard out is the first file descriptor, number 1. String, hello world, is the pointer. Length of the string will be, we set it to 10, so it's going to be printing out less. So let's make that again, and then let's run. Let's see. Make clean. Can we clean that? Or is it just, no, okay. rm hello. We'll rebuild this. Okay, rm hello.o, and then we'll say make again. Okay, we remade it. It's remade. So then we should just be able to / hello, and it should print 10 characters. It should print 10 characters. All right, so it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should say hello world. It should end at hello world. It didn't. It certainly didn't. Why not? Why didn't it work? Hold on a second. I said 10 characters. Why didn't that work? I feel like I'm getting I feel like I'm seeing a problem here. Does it need to be null terminated? \0, something like that. RM. Let's see here. Let's try this. Why did that not work? Why didn't it work? Let's assembly language to any use of AI this time in 2025. Kareem. I don't know. Time's flying, and a lot of AIs are taking care of business. You should have a man page that you can look at for assist calls. That would be great, Neva. That's what I want. That's exactly what I want. I have it somewhere. I need to go find it. It is terrifying, Eddie Legendary. It is terrifying. Let's see. Back to okay. I forgot the link to your. So you're running the old code. Wait. Neva. What old code are you talking about? Maybe I don't know. Okay. Let's get back into this. Why did that not work? That should be printing out exactly 10 characters. Let's rebuild that ls. Here we go. Let's rebuild that. rm hello world and hello world dot o. Okay. Make / hello world. Okay. So now it printed out hello. It printed out hello world without a D. Was that because I put the \0 there? What if we put the \0 here? Let's see. Let's do like one. Let's do extra characters here. Let's do this. Let's go here. Okay. Let's rebuild, make, and then rerun it. Okay. So it is working. Okay. So it's doing what I thought. It's just that I might not have removed all the things that we needed to remove. Okay. So we're on the right track. We know what we're doing here. We know what we're doing. Yeah, so you're running the older code. Yep, that's what it was. I was absolutely running the old code. You're totally right. Current course in data structures in your university. You should learn assembly language. It's worthwhile. It brings a lot of understanding to how applications are built and how they interact with the system. I think it helps from a knowledge perspective. It helps you learn how things are being, how things work. You could even write your own programming language. If you know assembly, then you can write your own compiler to compile it to an assembly language, right? Which we have here. So this helps you along the way. It helps you along the way. I don't think it null terminates. You're right. It does not. It does not. So watch this. If we put the null terminator like here, what's it going to do? What's it going to do if we put the null terminator there? I don't know. Let's see. Yeah, it does not null terminate. You're right. This is a specific programming language thing. So we got it. We know what we're doing. Things are happening. Steven, do you think you will ever do like a long stream? Like, multiple hours? Maybe someday. The thing is, I've got a lot of work to do every day in like real business, in the real world. I've got a lot of work to do every day, which means that I have to do other things that are not streaming, right? ASM for like system programming is gonna do a little bit of it in Unity. Yeah, in University. Yeah, you got it. Neva. You got it. Let's see here. Handmade assembly compilers are fun. Although, if you want to make one for real, try LLVM or something. Oh, good advice. That's good advice. Okay. Hey, I tried sending a list of syscalls and the commands. Oh, did you into the Discord? Not the website. Another one. Write syscall does not care. The write syscall does not care about null terminator. Yep, it does not. You're right. It doesn't. Just the length, but you can make a print function to check for nulls yourself, and it will be easier to use. Hey, thank you. Thank you for mentioning that. Thank you. That explains a lot, doesn't it? It explains a lot. Yeah, I got a friend in the TUM where he's just starting with assembly. Nice. All right. Or hear me out, ASMR for system programming. That is a whole vertical on its own, right? I was thinking about that. That would be a lot of fun. You could whisper all the things I would whisper. I don't know if you could whisper hello. I don't want. I'm asleep now with the Tech Man. Cool. Sounds great. Enjoy your sleeping. Bye, everyone. Or have a good night. I think there's a trick in ASM where you can do that. If you know ASM, you can train yourself evolving malware. Basically, produce sequential ASM line. Drawing Brothers, you're right. Label text. Wait, what does label text do? All right, Neva, help us know. So label, and then data type, right? This is kind of like a struct as far as I understand it. Like you can do something like that. And then I think you can have more stuff in here. I think you can do more there. I forgot how to do that. Okay. So we can drop this down just to hello. Let's do that really quick. Let's modify this. So go back over here. Nope. No, wrong. Okay. Thank you. CD chapter 1. Let's see. Get rid of that. go back over here, cd chapter 1. Okay. Vi hello dot s. Okay. Let's see. I want to only print out the hello part. So, right? So the hello is 5 characters. So we should be able to say 5, and then just of this string alone, just of this string right here, we should be able to say hello, right? I do believe we should be able to. So let's do this. Rm hello, and then hello.o, and then make, and then ./hello. Hello. All right, we did it. As you can see here on screen, just the word hello. Just the word hello. We got to print it. Let's see here. I'm clipping that. All right, Kyle. Sounds good. Clip away. So basically, do a label directly after text to get a pointer to the end of the text. This can be used to get the length. Oh, really? So then I don't have to like manually figure out what the length is every time, whatever string it's going to be. Whispering. I now added proper memory barrier. You could do that. I sent something completely normal in the Discord. All right, ID Legendary, we'll check it out. A decent assembler should give you math on constants. Nice. That would be great. Now, it may break because linkers are funny. Okay, that's good to know, Neva. That's good to know. All right. Whoa. All right, we got a lot of stuff going on here. What's going on? Let's see here. Okay, so we got, what is this? We're sleeping in, you guys. We're sleeping in. The alarm. We're just gonna sleep through it. We're sleeping through it. I do not like that sound. I do not like that sound. That is not a sound I like. What happened here? Okay. Okay, Kyle, you got a whole bunch of text that showed up. Oh, check this out. I don't know about this. I'm not sure about this. Let me check. System library, kernel farm, versions, header, syscall. Okay. All right, syscalls. Let us check this out really quick. We're going to check this out. Let's see here. Vi. That does not exist for me. That file does not exist. That is not a file that exists. Unfortunately, let's see. Let's see here. Nope. Nope. Let's see. I'm going to see where is Xcode. That's not where Xcode is installed, apparently, for me. That's not where Xcode is installed. So, oh well. I've been reading the Rust official book these days. Now I'm Rusty Guy. You are Drawing Brothers. Rust is fantastic. I love that language. It is a beautiful, beautiful, fun language that is very easy to use unless you get into the generics and the lifetimes. And you don't have to get into those things. You can completely avoid them and build beautiful language, beautiful coding. You need Xcode installed? I do, Kevin McAllister. I've got it installed. I sent the file to. Nice. I've got it installed in a different location. It's installed somewhere else. Oh, here we go. This is what I want. Yes. Yes. Okay. Vi download message. Here we go. Yeah. Wait, let's double check this. Let's double check. All right, number 4. Right. There we go. There we go. That's what I wanted all this time. Thank you so much. Thank you for posting that. Thank you for sending the whole file. Thank you, Kevin McAllister. Thank you. Thank you so much. So as you can see here, these are all the different system calls you can call. So right here, this is the line where you say what system call you want to call. You just put a literal into X16, the X16 register. It's different on different assembly targets. It could be R8, for example, or a different register. Bence, man, yeah. Hello, too many pseudonyms. I know, right? You got too many pseudonyms. Pseudonyms, you guys. You can just use Linux syscall table. It's 99% compatible. It is, yeah. That's what I want. You got it. You got it, Simone. You got it. That's what. This is exactly what I wanted. I like this. All right. So where is open? Open. Here we go. So we could do open. We could learn that. We could write. We could read. We could even read. Check that out. You could fork. You can exit. And I do believe this is the exit right here. All right. It's back there. Tab in. Okay. Pretty neat. Pretty neat. Link and unlink. Not sure what's that about. Oh, you can make directories. You can do different system call things here. You can accept inbound data. Get sock. socket stuff, networking level stuff. Syskill? You can do syskill? You really? That's crazy. I didn't know. Get a whole bunch of different things here. Anything you want on the system. Except reboot. You can Ooh, there's a good one. Don't accidentally do that one. Don't accidentally click 55. That would be a problem. Look at that. Whoops. Why is that one tucked right in there, right next to like ch root and other things? That's kind of crazy. What else we got? Groups. Okay. Operating system stuff here. Select. Okay. See socket, connect. All right. Networking level stuff. Great. Bind, listen. Nice. So you can accept inbound network traffic. Very nice. And then a different kind of read and write. Some chowns. Some ownership things on files. Shutdown. Oh, there we go. There's another good one. The shutdown. Turn the computer off. Look at that right there. Right next to socket pair and make directory. Isn't that great? The shutdown command to turn your computer off just so happens to be right nightly. Like, why'd they put it there? Why did they put it there? If you're on GCC or C-Lang instead, as you could use the name directly. Oh, nice, because you could, have the big. You could just use this name here instead of the constant. That's nice. Instead of the literal, you can just use a constant like this. That would be great. Not to beg, but can I get mod? Sure, Eddie Legendary. Let me pull this up here. Let's do that. All right, so let me go over here. 1 second. I'm going to click the buttons. It's going to happen. All right, so where is that at? Let me see. Let me see. Where are you at? Over here. Okay, here you go, Eddie Legendary. Click to mod. Add as moderator. Here you go. Eddie Legendary. You are now the moderator. Look at that. You asked me to receive. Let's see here. Yeah, and then tell you what. Let me see. 1 second. Here we go. Okay, perfect. All right. 1 second. Sorry, I'm not caught up with all the chat messages. I'm running behind here. I'm running behind on the chat messages. Let me see if I can pull this up here. Don't give him mod. He's social engineering you. Look at his PFP. Oh, well, too late, Kyle. It's too late. He got it. Do we have to remove it now? If you make Eddie a mob, you'll hear the oven sound all the time. No, Kevin. I know, right? Let's see. 1 second. Did you remember my GitHub issue? Even though I solved it, GitHub still shows tabs for a selected year. Yes, I remember that. 2012, right? It showed 2012. As it still shows all those years. Even after you fixed it, it still shows the whole number of years. It doesn't show anything there anymore in year 2012. I remember that. I remember it. Sorry, Eddie, I was joking. You're great. Okay, good. Thank you, Kyle. Thank you. It was literally nice, just a symbol with GCC. GCC was great. I like GCC. I used it a lot. Don't mod you. Oh, okay. Wait, Kyle, do you not want mod? Well, wait, hold on a second. You didn't ask, and then you received anyway. Okay. All right. Everyone's a mod now. There we go. I think it's really funny. Your math tips playlists actually show useful up until just autoplayed till a case something else is populating us with decoy. Oh, really? Oh, no. I'll take mod. Okay. You got it. You got it now. All right, where was this? Here we go. Let's click on some. Here we go. Let's see here. Clicking button. All right. I forgot to turn on the music, so we got a little bit of music going there. All right, get the music going. Okay. 1 second. I'm blue. If I were green, I would. That's how it goes. Right? I don't know. Wait, I don't know what you're talking. Are you talking about a song? Eddie, we have beef again. I reached your power level. All right, you reached the power level. You did, you guys. I think it's really fun. Okay, green. Okay, got it. Green. Okay. Green, you guys. Okay, here we go. Okay. So now that we did that, and then now we've got, right? Thank you, Kevin McAllister, for the list. Okay. So the system calls. Now we can call anything. If I just so happen to put this number here, wait, what is the number? 155, right? What was that? Wait, shut down. No, 134. There we go, 134. Uh-oh. If I run this, it'll end everything. The stream will be done if I end this, right? Wouldn't that be neat? Wouldn't that be a neat end to today's stream if I just executed this command right here to terminate the system? Do you think that'll work? Do you think that'll work? I don't know if it will or not. I don't know if it will. It might terminate. It might terminate. It might shut down the whole computer. IDKY, your playlist was there. Just random Onion news report in there. Was it? All right. That's how it goes sometimes. Do we have a beef with? Wait, who's this? Who's Kinde? I don't know who that is. Yeah, there was some junk I need to clear. Thanks. The whole chat is blue. Is it? Everyone's a mod now. Yeah. That's hands-on mod squad. You got it, you guys. Everybody's mod. Who's the one mod who's not a mod now? Oh, Drawing Brothers. All right, Drawing Brothers. I dealt with process injection malware, so I need to learn more deeply, but I've not dealt with the Win API with C++ before. How do I get started? Rust, by the way. Well, I don't know. I haven't really spent a lot of time in the destructive world of computers. I've mostly spent my time in constructive, where we build things. So we could probably figure it out if we spent some time on it, though I've been mostly constructive and not destructive. All right, so maybe if we make sure not to do that. All right, save that. All right, double check. All right, close that. Okay. Let's go to chapter 2, CD chapter 2, so we can CD chapter 02. All right. Let's see here. Vi add. All right. This is where we did some math. In chapter 2, we did some math. .assembly. Okay. So, well, that's gone. Where is this? Add 1.s. Okay. There we go. Okay. Let's bring this up here to the top. Let's close this window here. Close, please. Actually, close it. Close. Thank you. Okay. Okay. Can somebody, let me zoom in on that real quick so I can see it. Can somebody write something so I can delete it? I want to feel the power. You want to feel the power test. Here you go. Oh, never put something in. There we go. There we go. Okay. All right. So let's look at this. Okay. So we've got a different kind of register now, which is W instead of X. Let's do this. Let's look at this. All right. So this is an example of multiplication by -1. Moving, which I believe is going to modify the high bit or the low bit or something. I'm not exactly sure. So, okay. So we've got register 0 is going to be the number 2. And then W0 is going to be self-placed modified. We're going to say add. We're going to add 1, which should make this 3. I believe this should make this 3. And if we do it again, it should make it 4. Right? It should make it 4. So CD chapter 02, ls, make clean, so we make it there. Okay, so we should be able to say // what's this file called again? It is not that. Okay, here we go. There we go. Oh, that is annoying. Okay, so that is very annoying. Okay. Oh, see, there's like a Gemini configuration here. 1 second. Chrome settings. It has. Okay, we need to make it not that. Edit. Okay. Let's see. Wait, let's try that again. Okay. 1 second. Perfect. Okay. Now we should be able to do that. Perfect. Okay. Google Chrome has apparently taken over my Control G keyboard shortcut, and I had to set it. So it took over my keyboard shortcut. There we go. We fixed that. That's all good now. We're good to go now. Let's see here. We're quick. Okay. What's the thing at the top that popped up? That was Gemini. It took over because I was trying to do Control G to see what file I was in. So you can see here at the bottom, at the middle of the screen, you can see that it shows what the file name is. Control G in Vim or Vi will give you the name of the file. And I needed that. And Google Chrome took over. It took over. Let's see here. I love how we get free AI inside open code. That's AI using the organization on your files. Is it? I did. Oh, really? In open code? I didn't know you could do that. That's actually kind of neat. Hey, Quantified Quantum, how's it going? Hey, welcome. Happy Monday. We can't delete messages of equal or higher rank. Are you serious? You can't? So if you're all mods, you can't delete each other's messages? Really? Chapter 2. Oh, tired of. Hey, tired of. Chapter 2 is our Hello Silicon, which is assembly. We're doing assembly language. Like you can see here, there's an icon here or up here, depending on which stream you're looking at. And it will show you that we're doing assembly programming. That's what that means. That's what that icon means. That's all that means. If we're all mods, then no one is. I know, right? Yeah, exactly. Everybody's a mod. You all get mod, you guys. Yeah, Gemini thing is taking command is annoying. It is. I took care of that. It's gone now. I can get my thing back. So we should add example 1. That should be able to run. And then we've got a trace trap because I think I had a break statement here. So we should be able to comment that out, clean, and then make again, and then rerun that example, and it should not trace trap. Okay, excellent. Let's add that back, re-clean everything, and then remake it, and then do LLDB add. Wait, can I paste that? No. Let's see here. Let's do this. Copy that, LLDB, and then we say run. Okay. This allows you to. So if we're still following along here, I'm still trying to like make progress here. If you're still following along, we just ran the program with a break statement, which allows us to track the value of each of the registers. So like W0. At this point, W0 should be 4, right? How do we print out W0? Let's see here. Let's see here. I'm going to read through some of the chats to see if I miss anything. Now we need a mod. Oh, we got a mod. Everyone, right? I know is a assembly, but in command line it says chapter 2. Oh, got it. Sorry, tired of. I just saw your message there. The command line it says chapter 2. It's just a different directory. So we've got all these directories here. So let's see here. LS. So you see here on the screen, we've got a whole bunch of different directories, and they're all just various chapters, and they are referencing an assembly book, though we don't have the book. We just have the code. So we're doing our best to figure things out all on our own. That's what we're doing. We don't, print money W0. Oh, let's do it. Okay, excellent. All right, here, let's do it. All right. As you said, print money W0. Boom. Unsigned integer. That's very big. Hold on a second. Wait a second. Why is it that giant number? What's going on here? That looks like a very big number. It looks like the maximum 32-bit value, doesn't it? Or it looks very close to it. Why is it this giant number? So it is 123. It is 4.2 billion. So that is essentially, I do believe, the maximum integer value, or very close to it, for a 32-bit integer. Why? Why though? Why? All right, here. Let's save that. We'll just try it again. Delete, clean. Let's do make, clean, and make, and then and. So we can do this all in the same. So LODB, paste, go. Oh wait. How about we do semicolons then? I guess we could do semicolons. Make, clean, make, and then run. There we go. Run. And then, let's see here. Print. It's still, well, it's different. It's different this time. So it is it bigger or smaller? 1 second. It is 95, 94. It's small. It's smaller. Okay, that makes sense. It's either minus something IR or a pointer. Wait, Neva, hold on 1 second. Is there a way? Why? It's a pointer? It's a pointer. Okay. We're figuring this stuff out. We're figuring it out. W0. Okay, so if we set, right, we set W0 to 2, right? Or is that a pointer to 2? Number 2 is a pointer. So do we have to zero it out? So is this saying this is a pointer? Is that what that is? I'll have to look into Hello Silicon. It looks interesting. Tired of it. I'm enjoying it. I think it's a lot of fun. It's really neat. So you stopped before the set. Which set? Neva, I see you have math trick tutorial. Cool. Careful, Steven. You can only have a small amount of 200 mods total. Oh, really? Okay, Torva. Good to know. Everybody's a mod now. Now it contains the environmental variables? Really? So how do we set... How would we move in? Okay. Now it contains the NB bars move in. Okay. Only 200. That's still a lot. That's a lot of mods. That's except for you. I know, right? Everyone except for Drawing Brothers. Everyone except Drawing Brothers. And then hey, there's got to be someone who's not a mod. No, you just need to do step. What is step? Your debugger is weird. Is it? Step. Print. Step. It is LLDB, so it's not GDB. It's LODB, which you need to use when you're on like a Mac. When you're on Mac. I'm not a mod. Hey, Kelvin Callister's not a mod either. Well, okay, so we've got more than one non-mod at least. We've got a couple of non-mods now. It's like the issue isn't the code, it's the debugger. Oh, got it. Okay. So got it. Okay. What I'd like to be able to do is set this to 0. Let's see what happens if we set that to 0. And then set it just to 0. I'm going to see what that looks like. All right. Rebuild. Run. Print. Interesting. So that's not 0. That's not 0. Move in moves the inverted value. Oh, because it's in. Move in, not move. Okay. So that's why you're seeing the big numbers. Hey, thank you, Simone. All right, let's try that. Let's do this. Move regular. Move regular. All right, rebuild it. Run. And then we will print money W. Yeah, there we go. All right. That's what it was. Move in means move negative. Okay. Invert it. It means inverted. Hey, we're learning new stuff. Here we go, everyone. We're learning new stuff. Thank you, Simone. Thank you for doing that. That was really valuable. Off to the races. Now we can add. Let's see. Let's add 2 to 0. Let's add 2 to 0. Let's add 2. We'll add again, and we'll add again. We'll add twice. Let's try that. Let's make clean, and then we'll run, and then we will keep giving permissions for whatever reason, and then we'll say print money 0. It is 2. Here we go. Look at that right there. Beautiful. Now we're doing math operations, you guys. All right. See you guys tomorrow. All right, Drawing Brothers. Good to see you. Good to see you. Thank you for stopping in. Oh, why is it not just move? Because that was the tutorial. The tutorial is like, we can use, like, here, check this out. This is what the tutorial is. Multiply by -1 using move in and then add 1, which does some sort of trick. Some sort of trick. I don't get it. So that's what happened. Let's see here. All right. This is fun. I like this. This is great. All right. So let's see here. Okay. Break. Okay. So looking good. All right, so what if we add 10 and 10? Should be 20 now, right? Let's just we're messing with it now. Run, allow, and say print. It is 20. Yep. We're figuring it out. I don't know much about LLDB. Can you explain what that is, Kevin McAllister? Are you familiar with GDB? GNU debugger. The GNU. It's like a debugger that you can use to debug things. It's like a regular debugger. So any kind of debugger, but it's best for, in our case, for disassembling, right? So I do believe you can say disassemble. I know there's a disassemble command. So let's check this out. Vi readme dis. There is a disassemble. Here we go. So if we run this command here, I do believe we could disassemble the code. Here we go. There you go. Check it out. Isn't that neat right there? Look at that. Well, it's a lot more than I thought it was going to be. What's going on here? Wait, what's happening? Why is there so much? What? Hold on. Let's close that. Okay. Look at this. What is that can't be right. That's insane. There's not even that many instructions. What? It should. That's just ridiculous. LLDB is for linking, I believe. LLVM or LD for linking. LD for linking. LLDB is for debugging that. It's the same as GDB, but on Mac. You got to run it on Mac. LLDB for Mac. If you get the LLVM release, you get a debugger with it, assembler, CLang linker. It's like a lot of tools. You get a lot of tools. Yeah, you do. You get a lot of tools. Yeah, it's really cool. Nice. Yeah, I know it's a personality. Oh, is it? Wait. Me and GNU are essentially best friends? Oh, really? GNU? The good old GNU. The good old GNU. Debug system symbols and other executable wrapping. That's what it is. Oh, got it. That's why it's so much. You're seeing the linked in code like all the Dyn stuff is linking. Got it. Okay, so that's just a lot. There's just a lot. DYN. Yep, a whole bunch of stuff here. That's why. Okay. That's why it's 17 kilobytes. And the actual assembly file that we have here, add one, is only it's not even a kilobyte. That's crazy. Let's see. Can we say disassemble straight like this? No, we have to say start. And then it gives us a whole bunch of stuff. This is how you know you're talking to zeros and ones. Pretty much. You wish that Chodel send MP3 files here. Nothing to do with the oven thing. Like the timer or the alarm? Let's see. Yeah, it's surprising how much code is part of this standard lib. It's a lot. I was not expecting that. Maybe it's Mac security stuff. Oh, I didn't even think of that. That's actually a really good point. There's probably a lot more to it. I think you might be able to just not link like the O file. That would make sense. Okay, so can we say lldb.o? Let's see, 1 second. Oh, we can. There we go. That's it. All right, check that out. Hey, MCO or McDoon. MCO Din. How's it going? No, it's just UST-CLib. It's like the libc stuff. Got it. It's the standard lib stuff. There's always delay when running C programs. That's Mac security stuff, I think. There is always there is a delay. It's also it is security stuff. I know what happens because when there's an upgrade, it's happened this in the past. When there's a major software upgrade, like the operating system gets upgraded. You can upgrade your operating system, and then all of the hashes for the new binaries are changed, and you need to go check against the Mac Apple database, which is remotely hosted on Apple's cloud servers. Every executable has sort of like a hash, and it needs to be checked against their database. If it doesn't match, then it's a security vulnerability or a security warning, and it might not let you run the program. Or you have to give it special permissions to bypass it. Additionally, if you cannot reach the Apple servers that do this checksum hash, you can't even run your program in the first place. Your entire system runs to a halt. I remember this happening multiple times in my past when I've upgraded an operating system at the same time as the rest of the world. Things get really slow. Maybe there's something weird, but they also linking libc, which has some constant stuff. There's a lot of stuff in there. I was a lot more than I thought. Have you seen the dude playing Minecraft on 2 terabyte RAM? No, I haven't. That sounds like a lot of RAM. And you could probably get a giant world with that much RAM. A giant world. That's the signing process? Yeah, the signing process. Exactly, the signing process. You need to pay dev accounts for. Yes, exactly. You got it. Apple considers it all their private property. It is. You got it. It's all their private property. Okay. So we did, let's see, chapter 2. Let's see what we can do with chapter 3 here. And then we gotta wrap up. So we'll hit it with chapter 2. If you want to remove this stuff, try removing the LC flag from the from the LLD. Okay, let's try that. Neva, let's try that right now. Okay, CD chapter 02. Make file. Okay, let's see here. Wait, did you say remove or add? The LC flag? Try removing the LC flag. LC. It's not even there in the first place. It's not even there. I want to move to Linux more. Yeah, you should. It's great. It's a fantastic operating system. Ubuntu is great. It's a great start. Ubuntu is a very good entry point into your Linux adventure. If you want remove, it's not even there. I don't even see it. I don't even see it. Wait, I'm searching for it, LC. It's not there. It's not there, LC. Right? 20 minutes? Yeah, I know, right? Eddie Legendary, 20 minutes. He's probably one of the reasons of the RAM shorting. Yeah, he is, right? 2 terabytes? That's got to be expensive. It's so expensive. That's like $30,000 right now. I was thinking about this earlier today. It'll drop. Because what's going to happen is they're going to be able to make RAM inexpensively again, very inexpensively, because it's not that expensive to make RAM. The shortage will get flooded by a large market of someone who's going to profit generously. They're going to profit generously by lowering the price until it gets to the right price in the market, and it won't be expensive anymore. It might take a few months to get there. Still, 2 flags. The link, I don't know. There must be a lot. It might be the system flag here. We might need, that might be it. Let's see if we can make that happen. All right. Let's see, ls cd chapter 2. Make clean. Okay, let's try removing that. Make regular. Okay. It really wants that. I think it really wants that. Yeah, it needs that. We can't get rid of that one. What about syslibroot? What if we got rid of that one? Does it not like that one? Make clean. Yeah, it likes that one. It needs that one as well. Fabbing RAM on stream when? All right, wait. We could just lithography. We'll have just light beams onto silicon wafers, and we can make memory chips. You guys. All right. So that's what the build looks like. Those are the build commands. He played on some type of Dell server, I think. Oh, got it. Okay. That makes a lot of sense. That makes more sense. Consumer desktop with 2 terabytes of RAM. That's a lot of RAM. You need a giant motherboard for that much RAM. Problem isn't being able to produce all the major RAM gets produced for all the AI, so no longer DDR5. It is all the AI. It's all of it's going towards the AI manufacturing right now. Could Apple just requires a bunch of junk? Yeah, it seems like it. On Linux, you don't have to worry about it. Yeah. So here, we did check this out though. So we can. This is great. So you can do LLDB for the object file directly. So add example 1.0, and then you can say disassemble Wait, you have to say run first? No. Wait, we just did it. We just did this. Disassemble. Start. There we go. Perfect. Okay. So you can see here on the screen, that's the actual source code from the actual object file. So as long as we start with the object file, it works perfectly fine. It works perfectly fine. You need Linux, Steven. I'm running on Darwin. I'm right. We've got, right. What are we here? uname-a. Darwin. See, we're right there. We're running Darwin. We're doing okay. We're doing just fine. We got some Darwin right here, you guys. We're running on Darwin kernel. We're doing perfectly fine. Perfectly fine. We're doing good. Do you think it's worth switching from Ubuntu to Arch Linux? You can just call me up Odin. McDin? I mean, if you have a system that needs more performance and you don't want all the extra bloat well, there's not a lot of bloat in Ubuntu anyway. Then Arch Linux is going to be a very minimal install. So it could be a great way to revitalize an old system to make it just as fast as the rest of the world. You could do that. It'll be very fast. This reminds me of the meme that said 90% of the time, Linux users used to convince others to switch to Linux. They're already on Linux. They're already there. You use Arch, Eddie Legendary? Do you really? Do you really use Arch? Arch is like the Chad version of Linux, isn't it? It's like the ultimate. How dare you? I code Rust, so 99% of my time is spending convincing people to do it in Rust. I know, never. Exactly. Ben Thing Show, how's it going? What are you doing? I'm in. All right, so we are doing assembly programming. We're walking through some of the chapters, and we just did the chapter 2. And so right before we head out, though, I want to take a peek at chapter 3. I want to take a look at chapter 3. So let's take a look at that. Vi readme 3. Is there chapter 3 in here somewhere? I do believe there's a chapter 3 around here. It's around here. So chapter 3, tooling up. Okay. So I don't know if we need to actually deal with this because we just walked through it. We just did this. We just did this part. Wait. There's a command I want to run. There's a command right here. I want to check this out. What is this? Hold on. Let's check this out. No set wrap. Okay. There's a neat command here. I'm going to check this out. Oh, Mac Studio. Yeah, there you go. You got it. Just the meme, is it? Okay. I didn't know. Producing RAM chips from raw sediment. Kyle, you could, if you could do that, you'd be like rolling. You'd be rolling. It would be the way to go. Okay. Note that because we are linking a dynamic executable, the listing will be long and include other start functions. Our code will be listed under the line move example start. Likewise, the LLDB wants the breakpoint name without the underscore be start. Okay. To get the registers, this is what we like. We like the registers, you guys. We like the registers. To get the registers on the LLDB, we use register read. Although print seemed to do just fine. Register read, so R. So memory read, read, R-E-R, SPX1X0. What is this? What does this do right here? I'm looking at this right here. To get the registers on LLDB, we use register read or reread. Without arguments, this command will print all registers, or you can specify them. All right, let's do it. Let's check it out. Oh, okay. All right, let's see. Make. Okay, so let's see it. Make. We are good. Let's just remake everything. Make, clean, make, and then LODB. Add example 1. Run. Enable permissions, and then there was a break statement. Is there a continue? Continue. I think we're fine. We'll leave it there for now. So let's follow this example here. RER. So our register read. Whoa! Look at that. Check it out. This reads all the registers. Why doesn't it? Oh, look! It says this is neat. Look at that. Right there. Look at that. Oh wait, that's X. What about W? Is that the same? Oh, it is. Is it though? Wait. I'm actually kind of curious. Let's see here. This is README. 1 second. Read me. Okay, what is this? We can get rid of that. Let's get rid of this. Close that. Okay, vi add. Sorry, I stopped paying attention to chat. Sorry. CD chapter 02 ls vi. Add example 1.s. Let's see here. Microsoft support, yeah. I sent the video to Discord. Oh, cool. Okay, well, we'll check it out here. Maybe we'll check it out right before we end. Microsoft supporting, yeah, sure will on patch Apple support. That'll be $100 Linux support. Skill issues. Register values. I know the register values. Isn't it cool? I think it's very satisfying. Wait, is that printing state of the GPU or the CPU? Yeah, it is. It is. It's printing. See, RER, register read, does that. That's what it does. It's basically all the current registers, general purpose registers. What about the W's? So is it the same thing? I want to test it. All right, so let's do this. We'll do this, save. Let's open up this. Oh, wait, actually, we don't need to do that. We can go over here. Clean, make, LLDB, run, enable, and then reread. Okay. Hey, there we go. Okay, so that is the value, and it's hex. Okay, got it. It should have been obvious. That should have been obvious. Okay, so it's not the integer value. Well, it is the integer value, but not in decimal. It's in hexadecimal. Let's see. He's programming computer. Go back to punch cards. I know, right? The punch cards. This reminds me of when I was writing a CPU in Python and made a dump state function. You still haven't finished the CPU? You haven't? Soon, though. It sounds like a great project. That sounds like a good one. Okay. So that seems to be... I think we're on the right track. Exciting time to be in the world right now. Is it? I think so, too. It's if you were to choose to be alive at any moment in the world today, would you choose to be alive at the birth, or at least the right at the precipice of the AI, the birth of AI, right? The beginning of the Matrix. Isn't it neat to kind of be there at the beginning, just to see the beginning of the Matrix? I think it's kind of neat. I guess we're gonna find out, right? It's supposed to be 2 more years, 2028. All right, we'll find out. Okay. So, what happens when we don't do a break statement? What happens when we don't break? Make and then run, and then LODB exam. Oh, okay, yeah. Run. Allow. Okay. Exited. Okay. Are the registers still there? Reread. Okay. Register read. So you do need a break statement. Command requires a process which is currently stopped. Okay. W and X's are sizes. Oh, so it's still X is extra large and has the full 64-bit. W is half size. Got it. All right, Neva, thank you. That's great to know. So technically, we should be able to do that. Are these different registers, or are they the same register? So if I do X and mix in X and W, can you do that? Is it possible? Can you do that? Let's do make, clean, make, and then LODB, add example 1. Go. Run. Okay, allow. All right. Now, read. Register read. You can. It does. You can mix register X's and W's. You can mix the register X and W's. W is for the smaller 32-bit, and X is for the very large. Hey, check this out. You can mix them. I don't know why. So then why would... Well, if you're trying to, I guess, maintain a limit on your addresses, I guess, or your values in the register, you can basically zero set automatically the top stuff. All my experience seems impossible. Perfect distance from the sun. Perfect lifespan. Not interpreted all the data. Perfect tech phase transition. We're right there. We're making it. We're on our way. Okay. So before we head out, let's check out chapter 3 really quick. What is memory read? Okay. So what is memory read fxc4? What does that do? What does this do right here? Also, I want to try running this really quick. Let's see if we can run that. Rerun. Okay. Run. Allow. And then what does that do? Okay, so this gives, what is SP what is SP again? I forgot, what is SP? No, so the usefulness is to load 32-bit values to a register without needing to zero it out. Oh, okay. Move W01. Got it. Okay. Long left of stream. How long? How long of the stream? Maybe about maybe 10 minutes. Maybe about another 10 minutes, and then we'll be good. Not 20 minutes, not maybe 2 minutes. I don't know. We'll see here. I just want to finish a couple of things. Let's see if we can make it possible. All right, so that's neat. What if we do 2? What if we do X1? SP again, and then SP again. What is SP? What is SP? Is it a register? I guess it is a register, right? 20 minutes mentioned. Exactly, right? 20 minutes. Okay, so, Amit. Hey, Amit, how's it going? We're messing around with assembly code and the LLDB debugger. We are inspecting and disassembling, and we're stack pointer. Oh, stack pointer. Okay, gotcha. Stack pointer. I like how you did that in all capital letters. Thank you, Neva. 10-minute timer set. All right, great. SAQ 2000. It's a register that, by convention, does the function calls and stuff. Oh, gotcha. Okay. What are you disassembling? Just some assembly code that we've assembled, and then we've linked, and then we're disassembling. So it's just what you already see on the screen. It's just it's a toy, right? We're playing, we're investigating, we're learning. We are learning. So we could just say X0, right? We don't need SP. There we go. Isn't that great? I think that's great. What if we do, can we say step? Okay, what is XR? Okay, step again. Step. What do you think of PFP? I took the picture of myself. I don't know what PFP is. What is that? Anyone into metaphysics? A smidge. I appreciate metaphysics. You did 1 year of philosophy, right? Nice, Neva. Okay, so that was chapter 2. Let's keep going on chapter over here. Where's that at? Here we go. All right, I want to see what this does. What does this do? Memory read FXC4 address. What does that do? Where F is the display format. Okay, so X might be hexadecimal. S is the size of the data. Okay, so S4. C is the count. What's the difference between size and count? I don't know. All right, let's see what that does. Address, so do we say X0? Expression X0 evaluation failed. 1. W0. Money W0? Hey! Wait, is that it? W1? Okay. Oh, I see. I get it now. So 0. It's going to say 2, right? It's the decimal, or 2. Wait, is it yeah, okay, it's 2. Is it hexadecimal? What can we say? How do you say this? How do we put it? D? Can we say D? It keeps saying memory failed to read. So I'm not sure if that's right. Build for legacy, and you can time travel into the future. I like that. Okay. Stack pointer register. Yes. 2 in hex is 2. It should be, right? 2 in hex is 2. So X. It keeps saying memory read failed. So are we doing this right? Let's see here. Run? Yes. Okay. Read. Interesting. Okay. Address. Okay. Is it going to give us an example of that? LODB is even more powerful to display memory. The command is memory read, or mread for starters. These are the parameters used by the book. We don't have the book. We have the code example. Let's see. We just have the code example. Okay. So memory read, and then the address. So print, print, print money 0. So that's great. So print, that's what I really want. I want print money. What about X 0? Same thing? Yeah. Okay. So what about R? No, it doesn't know. What about K? No. Okay. We're just playing around. We're messing around. Okay. So W2. Okay. And then what is memory read FX C4 S4? I don't know. 2. Read fail. 1. What if we did 1 on each of these? What does this mean? Yeah, okay. For whatever reason, print does it better. Print is more exactly what I'm looking for. So there's that value. What if we, so let's make it bigger. Let's do, okay. Let's see. I need to change that. CD chapter 02. I need to here, I need to update my tmux file. Tmux. Tmux. Okay. I thought I got rid of this. Okay, let's see here. / here. I thought I deleted. Oh, I might need to okay, so I got rid of that. Okay. No worries. Okay, so what if we make this bigger? I want to make this into print hands-on. That's it. That's what we're doing. We're doing hands-on, you guys. I think this is an old book because address randomization should make it basically not possible to work with the constants. It is. I think we are dealing with some old stuff here. How old is it? I don't know. Let's find out. Get log. It says, well, it says this year, 2025. It says by Alexander von Below. Alexander von Below, March 25th, 2025. So we're not too far off. Let's see here. Yeah. Try to read. It's not mapped to anything. I want to try this out really quick. I want to see what this does. Let's see here. All right. Make clean, make, and then LODB add. Oh wait, it's not. Is it not there? Oh darn it. Chapter 02. All right. Make clean, make LODB add 1. Okay. Run. Allow. Okay. Print money X 0. So that is 20. But what if we say RE read X 0? So there it is. Okay, so hexadecimal it's 14, right? And then in decimal it's 20. All right. So that's all I was trying to do. I was just trying to see if I could print to see if we can get it to print out in decimal format, and we did. We did it right here. Really easy, right here. Easy. High five or prayer emoji? High five. The book it refers to is probably. Wait, I already read that. Sorry. The book references communists. Does it? It's from the 50s. Is it? Maybe. We're just looking. I don't know because it might actually. Because it is referencing, assembly language. This specific code base that we're looking at is specifically for ARM code bases. I need to go to. All right, sounds good. I understand. Okay. We're making our way. All right, so the last thing we're going to do here is chapter 3 investigation. Let's see if we can see what that looks like. Let's keep going. So we did the memory read, Apple Xcode, focus on building. Okay. All right. Okay, actually, I think that was it. I think we already did it. CD. We just did everything in chapter 2. All the chapter 3 things that we wanted to do, we actually did in chapter 2. So we did it because we're doing 64-bit ASM. You're right. That's it. Yeah, we are. You got it. Okay. All right, you guys, we're basically done. Is there anything else that we wanted to do before we go? We basically were able to, I think we did pretty good. We did basically a summary of what we've been working on with assembly so far, and we did some debugging on the debugger with LODB. We also read memory from the registers. We had a break statement. What do we do here? And we did some math, some easy, quick math. 1 minute left. I know, right? 1 minute. And then, boom. We messed around with the registers. We tried, doing different ads. We messed around with printing different system supervisor calls. 50 seconds, 20 seconds. Tell us how to think like a CTO. Well, every CTO is different in every business. So you can have, even though it says chief technical officer, you could still have like non-technical, what I call non-tech or non-coding CTOs that just work on maybe the software, or there might be more information technology driven. They might not be software engineering driven or architecture driven. So it really depends. You could have CTOs that are sometimes VPs of engineering, where they lead teams and grow teams and then organize teams with Scrum and things like that. So there's a whole bunch of different kinds of CTOs. Or you could be me, where we started a business and had a co-founder to take over most of the business side, and then I wrote the software, so I'm on the technical side of things. So you could have that kind of CTO, where I know all the code as much as possible and how our entire infrastructure works, and I can actually do hands-on and get things done and actually write code. So you could be that kind of CTO. So there's a bunch of different kinds of CTOs out there. Maybe they do hardware. Yeah, you're right. Exactly. Maybe there's a hardware-focused CTO who's specifically into microprocessors and sensors and things like that. Got it. Thanks. Yeah, absolutely. Happy to help. If there's any other questions, let me know. So I own a company, PubNub, and it is PUBNUB. We are Series E company, where we've raised 140 million. We have over a billion devices on my network. FPGAs, you got it. FPGAs, and we connect a lot of different things. And this is what I do. So a lot of our infrastructure is written in C and Rust for performance, and we're migrating all of our code to Rust for performance and scale perspective because we've got a lot of devices. And we run Kubernetes. We deploy all of our code in Amazon AWS across all of the regions, and your devices connect to the closest region. So that way you have really good messaging. And that's what I do. I help. I work with the team. I work on R&D. I check out different things. Connectivity equals business. You got it. Connectivity equals business. And it's really easy to just get started. You can easily subscribe to a channel, my channel. Click subscribe, and then you can send data to the channel. Send. There you go. And you can send whatever you want. You can send images. You could send code. You can send code like JavaScript. You should not do that. Or don't do that. You should always send data. But if you wanted to, you could send code. Hello, right? You say hello. Publish that. And as you can see here on the screen, data sent and transmitted anywhere in the world. You do not need to worry about IP addresses or anything like that. Devices can send and receive data. Are you building a mobile app, a game, an embedded IoT device with embedded hardware on a microprocessor or microcontroller? Do you need people to migrate code? It sounds kind of cool. Nevo, we actually did most of it. There's only a couple of components left that are not in Rust. And we're very close to a full Rust code base on everything. It's really great. It's really great. And there have even been some problems in some other code bases that we've had in the past. And we migrated it to Rust, and the problems are gone. And it's like immediately. It's amazing. It's great. I don't think it's good to have that many devices on your internet. If it's not McDonald's Wi-Fi, you can't be. Yeah. There's a lot. 1 billion is a lot, you guys. Can I use the QR code? Yeah, absolutely. Let's see. Is it around here? Here you go. Here's the QR code, if you can see it on the screen. And then if you use the QR code here, you'll be able to send data to my screen right now. Like here's my hands, like no hands. So if you actually use that QR code here you see on the screen, you'll start seeing data show up. You'll be able to send a message. Oh, yeah, right? Isn't it neat? Then you can send a message to him. You can. Eddie Legendary, you absolutely can. And it goes over my network, and you'll see it'll be very fast. It'll be super, super fast. The only latency that you'll notice is probably from the stream latency, which is a few seconds behind. To me, though, I see it instantaneously. The stream will lag just a smidge, though. The stream will be just a little bit lagging. Just a little lag. Just a little bit of a lag. Isn't it interesting? Sorry, I thought I heard an alarm or something. Oh, I did hear an alarm. Okay, I'll be right back. Don't send anything crazy. Don't send anything too crazy. I'll be right back. wait, I just got Steven's, BRB 3D printing? Oh, 3D printing! All right. Okay, I can't get the QR code to work on my phone screen. Oh, is it too, here, I'll zoom in on it. That might be a little bit difficult to get. Cause the stream, it won't let me use it. I wasn't zoomed in probably far enough. That might be enough now. Let me try it. Let me see if that works. I'm gonna try it. Here we go. We go, QR code. All right, good. There it goes. It works. Let me see here. Oh no. Sorry, you guys. Oh. We recently upgraded what phone do you use? Okay, sorry. So you're going to see a screen that looks like this. This is not what you're supposed to see. You guys might have been trying to interact with this page. You couldn't. It wouldn't work for you because this is a bug. Okay. I will tell the team about this and we will get it fixed. Sorry. That is a my side problem. That's my problem, not a you problem. Sorry about that. Okay. We recently upgraded this tool and it's a much better tool. However, in this scenario, it does not work with, it doesn't work here. That page does not work. Let's try this. Let me try this other QR code. I'm gonna see if it's the same thing. I think it's the exact same thing. Let me try this one. I think it's the exact same thing. Okay. Yeah, it is. Okay. Sorry, you guys. All right, we'll fix that. We'll fix it. We'll make it so you can do that in the future. Sorry about that. It's good improvement. I know it is. It is. Okay, you guys. Thank you. If you have any questions, let me know. Join our Discord. Head on over to Discord. Obviously, you're already there anyway. You're probably already in our Discord. Okay. I do got to get going. It was great to see you all. We did a little bit of assembly. Oh, wait, are you going to make a JIRA ticket? Yeah, I am. I'm going to make a JIRA ticket. How did you know? That's exactly what I'm going to do. We'll be making a JIRA ticket. And we'll be filing a bug and say, hey, it does not work anymore. It doesn't work anymore. 400 million, no QR code. I know, right? I know. Peace, guys. See you all. Cool. We're headed out. It was good to see you all. We'll be back tomorrow. I'm not sure what we'll do tomorrow. I do want to get more into... We might do a little bit more assembly. We might do some more coding challenges. We might get into some Python. Python seems to be really popular on a common request. So we could do some more of that. Can you look at the 2TB thing? Oh, yeah. All right. Legendary. Let's do that really quick. Okay. Is this it? Oh, Minecraft versus 2 terabytes of RAM. I'm sure Minecraft might be able to eat all that RAM. Okay. Here we go. I'm going to click into it. 1 second.
This is Minecraft,
Oh.
the most demanding game in the world. It can consume any amount of your computer's resources. And this is a $15,000 computer that I'm gonna crash today using various Minecraft experiments. This PC has 2 terabytes of DDR5 RAM and
Okay. This is a very long video. I won't be able to stay for all of it.
locked in channel mode.
So we're just going to check out just a smidgen of it.
2 gigantic processors with a total of 128 threads and an RTX 4090 GPU, which I successfully adapted to this computer using a fire hose. The specs are absolutely insane for a regular PC, because this isn't a PC, but a modern Dell server on LGA 4677 sockets released in 2023. In the vanilla version of Minecraft, the system's performance isn't much different from a regular high-end PC. Even if I delete everything from the map, the FPS doesn't break any records. I've seen much higher numbers in this game. I installed a few mods for Minecraft, and neither the Bedrock nor the Java version of Minecraft can utilize 2 processors simultaneously. Let's see how many blocks in this game I can replace with TNT. For this, I'll use a special command to get an axe, which I can now use to select the start and end points of the block area. Now I type -- set TNT, and just like that, the blocks have drastically changed their religious beliefs. With this command, I teleport to the edge of the map to select the last corner block, move a bit away, and replace all the grass blocks with TNT. 37,000 blocks appeared instantly. Let's go further. 1,225,000 blocks took significantly longer for the game to generate, but we'll go much, much further.
All of them.
22,200,000 blocks took about 7 minutes to generate, which is quite a lot. Even though RAM usage increased to 100 gigabytes, but we'll push this as far as it can go.
100
so
gigabytes?
I teleported to the edge of the map again, selected a block there, then teleported to the opposite edge of the map and selected the final block. Now, let's replace everything with TNT.
It's
At
gonna
first
take,
glance,
like,
nothing changed,
hours.
but the command started executing, which means our magical axe isn't working right now. To give you some perspective, I'm currently trying to replace the entire Minecraft
Yeah, I know,
map,
right?
60
Exactly.
by 60 million
Now we look like those brain rot React short streams. That's what
blocks.
it's your fault.
That's 3 points.
That's your fault, Eddie Legendary. It's your fault.
6 quadrillion blocks. Each block is 1 square meter, meaning we're talking about 3.6 billion square kilometers, which is 7 times the surface area of our planet. After about 7 minutes, I noticed something strange. RAM usage started increasing, and quite rapidly, I must say. Almost 200 gigabytes of RAM is already occupied, which means the game is actually trying to execute this insane task. I also noticed that Minecraft, which normally uses just a single CPU thread, was now happily maxing out all 64 threads at full power.
Definitely
After
a trap.
about an hour,
Definitely
the
a
RAM
trap.
started filling up very aggressively, reaching almost 800 gigabytes used. The highest I saw
Wow.
was 900 gigabytes. Then RAM started clearing itself, only to fill up again. I did some calculations and figured out that executing this script would take me 11 years. So theoretically, it's possible, but I don't have that much time. Let's see how many TNT blocks we can detonate with this much RAM. I entered a command that generates TNT pyramids of different sizes. The 1,500 block and 170,000 block pyramids appeared almost instantly. Look at the huge difference between them. And on the right, a pyramid with 1,350,000 blocks. Looks impressive, doesn't it? But what if we create a 10 million block pyramid? This one took quite a long time to generate. Here's what a pyramid that's nearly 10 times bigger looks like. Even Mr. Beast's pyramids aren't as massive as this one. But that's still not enough for me, so I made a pyramid with 85 million blocks. It took about 40 minutes to generate, but just look at the results! This pyramid is so gigantic that I think I've reached the limit of pyramid generation in this game. Here's a comparison of all the pyramids by their TNT equivalent in real life. The final pyramid is as powerful as 7 of the most powerful nuclear bombs.
It reached max ceiling height, the max height of the world.
Each 50 megatons in size.
Yeah, I could use some of that RAM
Set them
too.
on fire and see how many pyramids can explode before the game crashes. Boom! The first 1,500 block pyramid exploded instantly. The 170,000 block pyramid took much longer. By the way, I've cut out all the freezes because this one took about half an hour to explode, and you're watching it in a fast-forwarded version. Oh, looks like the apocalypse is over. Oh no, poor donkey. I can't let him suffer. Better put him out of his misery while he's still alive. Strangely, he's not falling
He's not
down.
gonna fall.
Is this some kind of anomaly? Wait a minute, the sparks are still flying. Looks like the fireworks
It
aren't
didn't
over
finish
yet.
exploding.
Oh God, there are more and more sparks. Oh no! It seems the explosion has triggered the 1.35 million block pyramid. I think we should wish our PC good luck because this explosion is absolutely massive. The game slowed down so much that progress started taking literal hours. Sometimes it froze for half an hour, but it never crashed, thanks to our huge RAM capacity. The sparks are still flying on the left. They'll probably keep flying for the next 30 years. Watching this in fast forward is actually fascinating. By the 7th hour of the experiment, I was more and more convinced that our server would survive this pyramid. By now, most of it had exploded, and I estimate we've detonated around 1 million blocks, considering the pyramid originally had 1.35 million. This took up 165 gigabytes of RAM.
That's just
I won't
ridiculous.
continue any further because it's 2 a.m. and I need
It's
to
just so
sleep,
chaos.
and
This-
definitely
I
can't
love this
sleep
stuff.
with
This is great.
Vacuum cleaner running. For the next experiment, we'll need a command
Okay,
block.
that was all I wanted to see. That's all I wanted to see. I'm sure it goes on and it's more interesting. The TNT, that's the fun one. That was the fun one. All right, you guys. Thank you for hanging out today. I gotta get going. I had a lot of fun doing assembly programming with you. We might do a little bit more tomorrow. We'll figure it out. We'll figure it out what we'll do tomorrow. And we'll be back tomorrow. It's good to see you all. I'm headed out now. Thank you for the likes, you guys. Thank you for the heart icons. GG. It's been great. It's been great. Thank you guys. Eddie Legendary, thank you for the video. It was neat. It's neat to see that. And I have to make HTB videos. All right. Go for it. SAQ 3000. Go for it. Right. It's great. Okay. Bye everyone. Thank you. Thank you, Kevin McAllister. Thank you. I had a lot of fun working on the assembly. Really good. Nice to get back into it. I thought it was a lot of fun. See ya. Bye. Have a nice day. Have a nice stream. Hack the box. Hack the box, you guys. ASMR Steven. Coming soon. All right. Coming soon. You make. We could. Maybe. Probably not. Probably not. It was good to see you. All right, everyone. Thank you for your time. See you guys. We're just clicking the stop button now. Bye.